Hi, today I'm going to be showing you how I built and implemented a low-pass filter in Python. So here's my input audio. I'm not going to play the whole recording, but you can hear that there is some noise taking place. I just don't know at which frequency, so I'm going to take the fast Fourier transform. I'm not taking the CTFT. I'm using the FFT because it is faster. It is an approximation, but it gives me enough data for what I'm currently using it for. So first I'm going to take the Fourier transform, then plot out the magnitude spectrum in the frequency domain, so that way I can identify where this noise is taking place. So here, this is the music that we hear and sounds good. That's music to our ears. And then here's all the garbage that we don't like and we want to get rid of. This is all the noise. And we can see that's at higher frequencies, which is why we want a low pass filter in this case, to get rid of these frequencies here and to keep these frequencies here. So this is where I designed my low pass filter. I used LPF bands and LPF desired to do so. LPF bands is where I'm specifying where my pass band range is and where my stop band range is. In this case, 0 to 18 is my pass band range, and 0 to 0.18, sorry, and 0.56 to 1 is where my stop band range is. And that's because of how I have LPF desired set up with the 1 and 0. If I wanted it to be a high pass filter, then the 1 would be where the 0 is, and the 0 is where the 1 is. And it would make the pass band in that case from 0.56 to 1, and the stop band from 0 to 0.18. But right now we're doing a low pass filter. So we have our pass band and stop band range. The range in between is the transition band, which is basically where it's the region where I don't mind those frequencies being attenuated a little, and it's the transition between the pass band and stop band. The stop band are frequencies which I absolutely don't want to hear, and the pass band are frequencies which I definitely want to hear and I don't want any attenuation for. So signal.remise is the function I'm using from the library to actually build this low pass filter by giving it the proper inputs. And then right here, all of this here is me applying it and plotting it. So now this is what my low pass filter looks like. You can see that the transition band is this region right here. This is the uh, stop band, and this is the pass band. Uh, I'm not able to make an ideal low pass filter because we are dealing with real time signals. An ideal low pass filter has zero transition band, which is impossible for in real time. So we are going to have some transition band. It's just the goal is to make it as small as possible. And here I'm applying it. I'm applying this LPF to the original audio sample, and this is what the plot for that looks like. You can see that I kept all the music that we wanted to hear. There is a little attenuation in the middle, but all of those higher frequency, the noise frequencies are taken out from before. You can see here there's a big block of noise, and here I've gotten rid of it by applying this low pass filter. So this is what the new music sounds like. So you can hear that I've gotten rid of all the noise and I successfully applied the low pass filter.